CNC machining enhances precision and reliability in electronic component production by combining computer-controlled automation with repeatable mechanical accuracy. In electronics manufacturing, even the smallest dimensional deviation can affect functionality, performance, and long-term reliability. That is why CNC techniques play a critical role in producing components used in consumer electronics, aerospace systems, and medical devices. CNC machining operates through programmed computer instructions that control spindles, axes, feed rates, and cutting tools with high precision. Instead of relying on manual adjustments, the machine follows digital instructions developed from CAD models and processed through CAM software. The CAD model defines the final part geometry, while CAM software generates the tool paths and machining parameters required to produce it accurately. Once the machining code is generated, it is transferred to the CNC controller, which coordinates all movements during the cutting cycle. The workpiece is mounted, tooling is set, and the machining process begins. Because every step is digitally defined, the results are predictable and repeatable. This digital workflow minimizes human error and ensures that each component matches the original design specifications. The precision of CNC machines allows manufacturers to produce parts with extremely tight tolerances. In electronic components such as semiconductors, circuit board fixtures, microprocessor housings, and precision connectors, even thousandths of an inch matter. Computer-controlled positioning ensures that movements are executed with accuracy beyond what manual machining can achieve. This high level of dimensional control directly improves part fit, alignment, and performance reliability. Consistency is another major advantage. CNC machines repeat the same operation multiple times without variation, producing identical parts across large production runs. In electronics manufacturing, interchangeability is critical. If one component fails, it must be replaced without affecting the overall system. CNC machining ensures that each part meets the same dimensional standards, allowing reliable mass production. Modern CNC systems also improve reliability by predicting and preventing errors before they occur. Simulation software can analyze tool paths, detect potential collisions, and identify programming mistakes before machining begins. During operation, advanced monitoring systems track spindle load, axis motion, and temperature to maintain stability. If deviations occur, the system can compensate or alert the operator, reducing scrap and preventing machine damage. Different types of CNC machines support the diverse needs of electronics manufacturing. Vertical machining centers provide stable milling and drilling for enclosures and precision plates. Horizontal machining centers improve chip evacuation and support heavier cutting operations. Gantry machining centers offer enhanced rigidity for large or complex components. Dedicated CNC drilling machines optimize repetitive hole production for circuit boards and fixtures. Engraving and milling machines are used for labels, molds, and PCB prototypes, while horizontal boring machines provide accurate internal diameter finishing. For complex geometries, 5-axis machining centers allow multi-angle cutting in a single setup, reducing repositioning errors and improving surface quality. CNC machining is widely applied in electronics hardware production. Printed circuit board milling enables rapid prototyping of PCB laminates without chemical etching, allowing engineers to test designs quickly. Enclosure fabrication ensures precise housing for sensitive electronics, achieving proper fit and alignment. Component prototyping allows fast design revisions by updating digital models without new tooling. Connector manufacturing benefits from CNC turning and milling processes that produce threaded ports, docking features, and precision alignment components with high repeatability. By combining digital design integration, precise motion control, error prediction, and repeatable execution, CNC techniques significantly enhance both precision and reliability in electronic component production. The result is tighter tolerances, consistent quality, reduced scrap rates, and dependable performance in critical applications. If you're not following now, you may not find this explanation again.